Cities A and B are 45 miles apart. Alicia lives in A and Beth lives in B. Alicia bikes towards B at 18 miles per hour, leaving at the same time. Beth bikes toward A at 12 miles per hour. How many miles from city A will they be when they meet? Let's make a little diagram. We got A and B, and I don't know where they meet, but let's say they meet right here. So we'll call this X, and we'll call this distance 45 minus X, since the entire distance is 45. So then, oh, by the way, that's Alicia, and that's Beth. All right, so speed is equal to distance over time, or any variation of that is the formula we're going to be using. So the time would be obviously d over s. So we want a scenario where the time for Alicia is equal to the time for Beth. That's obviously when they meet. So that's going to be the distance for Alicia over the speed of Alicia, and that's equal to the distance for Beth over the speed of Beth. The distance for Alicia from there to there is x. The speed, do they give us the speed? I believe they do. Or sorry, for Alicia, what's her speed? It's right here. Alicia bikes towards B at 18 miles an hour, so that's 18. And then for distance for B, that'll be 45 minus x, and the speed for B is 12. That's Beth's speed. And there you go. That's the math. And if you cross multiply here, you'll get 12x is equal to 18 times 45 minus 18x. So that means 30x is equal to 18 times 45. So x is going to be 1.5 times 18, and that's 27. So x is 27, and that is choice E. The weight of 1/3 of a large pizza together with 3½ cups of orange slices is the same weight of 3/4 of a large pizza together with ½ cups of orange slices. A cup of orange slices weigh 1/4 of a pound. What is the weight in pounds of a large pizza? So the math, if I let the pizza be P and the orange slices I'll let just be S, and that's basically, you see, 1/3 of P and 3.5 of S is the same weight, so equals 3/4 of P plus 1/2 of S. And I think that's the math. So, and then they also tell me that the orange slices are 1/4, so that basically means that S is 1/4. So sub that in. So this is P over 3 plus 3.5 times 0.25, and that's 3P over 4 plus 1/2. I'm using decimals and fractions, which is a cardinal sin, but that's okay. So when you do this math, you get, let's see here, 0.75p minus 0.33p is equal to 0.875 minus 0.125, and therefore 0.75 will be equal to 0.416 repeat p, and therefore p will be 1.8. And 1.8 is the equivalent of which one of these? A, I believe. Yeah. So A is the answer to this question. How many positive perfect squares less than 2023 are divisible by 5? Well, first of all, we want a perfect square to be less than 2023. So that means the square root of 2023 will be what we're looking at, and that's approximately 44.9. So basically we want perfect squares, obviously positive ones, that the number is less than 44. So let's see here, that's going to be 5 squared, 10 squared, 15 squared, because they're divisible by 5, so they have to be multiples of 5. 20 squared, 25 squared, 30 squared, 35 squared, 40 squared, and then that's it, because 45 squared wouldn't be allowed since 45 is not less than 44.9. So how many did I get? 1, 2, 3, 4, 5, 6, 7, 8. And therefore the answer to this one is A. A quadrilateral has all integer side lengths, a perimeter of 26, and one side length 4. What is the greatest possible length of one side of this quadrilateral? Let's draw a quadrilateral. I have no idea what it looks like, but let's just say that's the quadrilateral. One side is 4, the other sides I'll call A, B, and C. And they also told me the perimeter is 26, so that means that A plus B plus C plus 4 is 26, and therefore A plus B plus C is 22. Okay, so that means C would be 22 minus A minus B. And, or I could write A plus B is equal to 22 minus C. I'm just trying to think what will help me here. Okay, let me see here. Let me concentrate on C. If C was like that, and I just had, I'm trying to kind of explain this. Let's say this is 4, this is A, this is B, and C. If you look at this, right, C has to be less than A plus 4 plus B. That's the only way you can make a quadrilateral. Because if C was equal, it would be 2 straight lines. It would be, like this. And if C was greater, then you wouldn't be able to make a quadrilateral. So this is very important, this right here. So let's take that into consideration and put that in there. So C has to be less than A plus B plus 4. Okay. Now, A plus B is 22 minus C. So C has to be less than 22 minus C plus 4. And therefore 2C is less than 26. And therefore C is less than 13. And they want the greatest. So the greatest possible side length of 1 is got to be less than 13. So the greatest would be 12. And therefore that's D. How many digits are there in the base 10 representation of 8 to the 5, 5 to the 10, 15 to the 5? All right, so, oh boy, so a lot of ways of doing this. Let's see if I play around with these numbers, what do I get here? And I'm sure you could probably find a quicker way. I'm just trying to see what I can do here. Well, I'll combine the 8 and the 15, so 8 and the 15 all to the 5, and then leave that alone for now. So that's 120. Okay, then the 120 I'll break up into 12 and 10. And then that's going to be 12 to the 5, 10 to the 5, and then 5 to the 10. Okay, so the 10, what do I do here? Let's see. I've got 12 to the 5, 10 to the 5, 5 to the 10. Okay, I'm going to break up that 5, this guy into 5 to the 5. So I'm going to put 1 5 to the 5 here, and then 1 to 5 to the 5 here. And that will allow me to combine these guys. So it'll be 12 times 5 to the 5, and this will just be 10 to the 5 and 5 to the 5. Okay, so then that's 60 to the 5, 10 to the 5, 5 to the 5, and then that's and let's see here, we've got, this is 6 times 6 to the 5, 10 to the 5, times 10 to the 5, 5 to the 5. Okay, if I combine that and that, that'll be 30 to the 5, and then this 10 to the 10. We're almost there. And then we've got 3 to the 5, and then 5 to the 5, or no, 3 to the 5 and then 10 to the 5. Yeah. And then 10 to the 10. Okay. So then we got 3 to the 5 and times 10 to the 15. So 3 to the 5, I believe, is 243, and then 10 to the 15 would just be 15 zeros. So we got 3 numbers here, 15 digits there, so a total of 18. So I'm just fiddling around with it to get E. If you guys can do it in a faster way, which I sincerely hope you can, then that's perfectly fine. I'm sure that there is a faster way. I'm just, fiddling around with these numbers to try to get, the goal really is to get as many powers of 10 as possible, and then the remaining number would just be a simple number that you could calculate. An integer is assigned to each vertex of a cube. The value of an edge is defined to be the sum of the values of the two vertices it touches. And the value of a face is defined to be the sum of the values of the four edges surrounding it. The value of a cube is defined as the sum of the values of its 6 faces. Suppose the sum of the integers assigned to the vertices is 21. What is the value of the cube? Let's draw a cube, and let's label it A, B, C, D, E, F, G, H. So I've labeled the vertices. And according to this sentence, the sum of the integers, so A plus B plus C and so on, is equal to 21. Now, the value of a face is defined to be the sum of the values of the four edges surrounding it. So for example, if I was to look at the top face, right, that value would actually be A plus B, that edge, plus A plus D, the next edge, plus B plus C, and then plus D plus C. So that is the value of that face. That's how I'm interpreting the question. So the value of the entire cube would be the value of all the 6 faces. So we'll have 1, 2, 3, 4, 5, 6 faces, and I'll write them all out, and then I'll come back to you. So that is the big long way of doing this question. I probably could do it a little bit faster, but I wanted to explain it thoroughly. Okay, so now we got to add these all up. And when you add them all up, you will quickly notice that you will actually get all of them to group in 2s, and that is going to be beneficial at the end. So let me just write them all out. B plus F plus 2 E plus F, and so on, right? So that is the good news of this question. And then eventually, as I hope you probably have figured out by now, you're going to use that point way up there, because otherwise there's no numerical data to go by. Okay, so then once all this is done, you group it, and you'll get 2 of each of these, the A plus B plus C plus D plus E plus F plus G plus H. Actually, you'll get 6 of them. Yeah, you'll get 6 of them. You'll get 3 groups of 2, basically, or whatever. I mean, it doesn't really matter how you group it. And that's 21, so 6 times 21, and that's 126. So the answer will be D. 126 is D. Janet rolls a standard 6-sided die 4 times and keeps the running total of the number she rolls. What is the probability that at some point her running total will equal 3? So she's going to roll once, she's going to roll twice, and she's going to roll 4 times, right? 4 times, okay. So when she rolls the first time, it could be either a 1, 2, 3, 4, 5, or 6. Now, the probability that at this point the running total is 3 is 1 out of 6, because the only way that she could have a total of 3 is if she rolled a 3. Correct? Okay. So then now, that's pretty easy. So now let's move on to the next one. We want a running total of 3, right? So the only way for that to happen is if the first roll was a 1 and the second roll was a 2. Or the first roll was a 2 and the second roll was a 1. So those are the only 2 scenarios in which the running total after the second roll would be 3. Now, the total number of rolls, you have 6 choices for the first guy and 6 choices for the second one. So there's a total of 36. So these 2 out of those 36 is the probability of getting a running total of 3 after the second roll. Okay, now we get to the third roll. The third roll, the only way for the running total to be 3 is if we had 1 for the first roll, 1 for the second roll, and 1 for the third roll. And there's similarly, there's 6 choices for the first roll, 6 choices for the second roll, and 6 choices for the third roll. So this probability, there's only one scenario here, so 1 out of 6 to the power of 3. And then to get a running total of 3 after the fourth roll is impossible, because even if you had 1, 1, 1, you would have to have the lowest. There's no 0, right? So this would be a running total of 4, so this is 0. Okay, so we want this or that. Or is the very important one. And if the probability question is or, you add them. So it'd be 1/6 plus 2 over 36 plus 1 over 6 to the power of 3. And you guys can add fractions, I'm certain of that. And when you do, you get 49 over 216. And that answer is B. Barb the baker has developed a new temperature scale for her bakery called the Bredis scale, which is a linear function of the Fahrenheit scale. Bread rises at 110 degrees Fahrenheit, which is 0 degrees on the Bredis scale. Bread is baked at 350 degrees Fahrenheit, which is 100 degrees on the Bredis scale. Bread is done when its internal temperature is 200 degrees Fahrenheit. What is this in degrees on the Bredis scale? So we have X and Y. And this is the Bredis scale, and this is the Fahrenheit scale. So when they're saying 0, it's 110 over here. When it's 100, they're saying 350. And then they are saying, what is it on the Bredis scale? So X when it's 200. Okay, and linear function, that's a very important. That means that the relationship between Y and X is a linear function, so like a line. Okay, I think I shouldn't be too difficult. We just use these as X and Y and then eventually plug in 200 for Y, I think. Okay. So when X is 0, Y would be equal to B, and then Y is 110, so B is 110. And then therefore Y is equal to MX plus 110. So then let's plug in that guy. When we have 350, X is 100, and then therefore 350 minus 110 over 100 is M, and M calculates to 2.4. So therefore, that equation is really Y is equal to 2.4x plus 110. And then when you sub in 200 for Y, you get 200, let's see here, minus 110 over 2.4 is equal to X, and X calculates to 37.5. 37.5 is D. A digital display shows the current date as an 8-digit integer consisting of a 4-digit year followed by a 2-digit month followed by a 2-digit date within the month. For example, Arbor Day this year is displayed at 20230428. How many dates in 2023 does each digit appear as an even number of times? An even number of times in the 8-digit display for that date. Okay, let me first try to understand this question here. So 2023, let me give an example. We want each digit to appear even number of times, and there's 8 digits, right? So 2 appears twice. So twice is an even number. 0 appears once. Let me just stick in another 0. 3 appears once, so we'll stick in another 3. And then let me put in 2 ones. And this is just an example. Let me see if this works. So we want each digit to appear an even number of times. So let's see. The 0 appears twice. 2 is an even number. The 1 appears twice. 2 is an even number. The 2 appears twice, and the 3 appears twice. Okay, now I have to actually check if this is a valid date. That's March, and that's 11th. Okay, because for example, if I put in this, that's not a valid date because there's no 13th month, right? Okay, so this is, I just did that to kind of understand the question. So the good news is that everything is going to start with 2023, right? Because they're saying in that year. So we just have to figure out the last 4 digits. All right, so let's start. I'm going to start with the 0, and therefore the zeros are taken care of and the 2s are taken care of. Now I've got to put in at least another 3. And then I'm going to put in another number, so I'll put in 1, 1. And that's actually what I had over here. So I've got my first twice now. My first number twice. Let's just keep going. Let's see how many we can make. Hopefully there's not too many. The 0 again, and the 3, and then I just thought of this while I was writing that because it's got to be 2, 2, but it can't be 3, 3 because there's no 33 number. Okay, let's keep going. 2023, put the 0 again. I've done with my, but the 3 I've done with it putting in that location. However I put in that location, and I put the 1 ones there. Is that a valid date? Is there 31 days in January? You'd think I would know this, right? Yeah, I believe there is. Okay, so that's a valid date. Okay, good. And so I think that's all it is. You just got to keep going like that. And what I mean is just experimenting. Okay, so let's keep going. 2023. Again, 0 here. I can't put 2 because that would be 32, and there's no 32 days in January or February or any month. So I think I'm exhausted with the 3s in that position. So I'm going to put the 3 in that position, and then the 1, 1 there. And then 2023 again, put a 3, and then 2, 2, and I think that still makes it valid. Okay, so these guys are all with the 0 on that, and I think I've exhausted that. So now let's move on with a 1 in that position. So I've got to put at least another 0 to match with that one. I've got to put another at least 1, 3 to match with that one, and another 1. So that is valid. Let's try again with a 1, 0, and then I can flip these. So there you go. And I think, well, I can't put a 2, so I've got to keep going with the 1 because there's no, if I put a 2 there, it was not going to work because there's no month and there's no 20th month. So let's try a 1 again. And let me just, I think am I just moving this 0, 3, 1 around? 0, 3, 1, 0. I think so. So how can I move the 0, 3, 1 around? 1, 0, 3. 2, 0, 3. 1 again. 1, 3, 0, I think. And I think that's it. Yeah, I think that's it. So how many did I get in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, and therefore the answer is E. Maureen is keeping track of the mean of her quiz scores this semester. If Maureen scores an 11 on the next quiz, her mean will increase by 1. If she scores an 11 on each of the next 3 quizzes, her mean will increase by 2. What is the mean of her quiz scores currently? So let me just give an example. Let's say that the mean is 6, and then how many numbers we have is 3. So that means we have let's just say we have a 6, 6, and 6, right? That's an example. So there's 3 numbers. That's why the n is 3, n representing how many numbers there are. And the mean in this case is 6. So the total would be n times m, which in this case is 3 times 6, which is 18. So I'm just trying to think about this for a second. So if I interpret the first sentence, that would basically be nm plus the 11 divided by the total, which in this case is n plus 1, is going to increase the mean by 1. So I think that's the mathematics of the first equation. And then the second equation, if she scores an 11 on each of the next 3 quizzes, so this time it's n times 11 plus 11 plus 11 plus 11. And now it's n plus 3 because we've added 3. And that's going to increase the mean by 2. So n plus 2. Okay. So I'm pretty sure those are the 2 equations, sorry. And I guess we just solve them. So we got n times n plus 11 is n times 1 times n plus 1 of m plus 1 when you cross multiply. So that's going to be nm plus 11 is equal to nm plus n plus m plus 1. Good news that nm cancels, and that means that n plus m is equal to 10, or n is equal to 10 minus m. And what are we trying to figure out in this question? What is her mean? So we're trying to figure out the value for m. Okay. And then this one, same kind of story here. nm plus 33 will be equal to n times 3 times m plus 2. And therefore n times m plus 33 is equal to nm plus 2n plus 3m plus 6. And therefore that's going to be 27 is equal to 2n plus 3m, correct? And then I'm going to sub in that guy because I'm trying to solve for m. So it's going to be 2 times 10 minus m plus 3m. So 27 is 20 minus 2m plus 3m. And therefore m is 7. And therefore 7 is the answer, and that would be D.